Hello, everyone. Welcome to DSSML 2024. So now we have another presenters from OLX group. So let me introduce them. Catarina Gonçalves, Ilan Dubois, and Marcin Gumkowski. And they will tell us a little bit about learning to rank framework, how to create an army of models. So thank you very much. And the floor is yours. Please start.
Yes, thank you. Hi, I'm Marcin. I'm a machine learning engineer in OLX Group. And yeah, we will talk about learning to rank framework today. But first, I would like to say a few words about OLX Group because it's crucial to understand the challenges that we face. We operate on a few continents: Asia, Europe, Africa, mainly in South Africa country. So we are on the more than 20 markets. We have 45 million active users on our platforms. And we based, three of us, we are based in different countries, but we support many of them. So we built our solutions not for one platform, right? But to satisfy the needs of many of them. For Polish audience, I think you can recognize OLX Group mainly from the OLX Classifieds platform, but also Otomoto or Otodom, real estate and motors platforms. OLX Group since 2018 tries to be, we want to be innovative in terms of AI. So we are specialized in the area of trust and safety because we have many phishing or some security breaches on our platforms. We also use ML to personalize our products. We are good in dynamic pricing. Our ads, we use ML to predict the optimal price for the platform, but also to not harm our users. But recently we also exploring search and recommendations area. And search we mostly try to optimize our rankings by ML solution. Agenda for today, because we will be talking about mostly learning to rank, I need to introduce learning to rank algorithm a bit. I'll try to do it in a practical approach, but later on I will show the use case in OLX. I also I'll mention about challenges that we faced, which are the motivation to create a learning to rank framework, which will be described by Ilan. And at the end, Catarina will tell us about status quo. So what's learning to rank? From theory, it's a machine learning algorithm for sure. The goal is to create a ranking model, right? To reorder items. And the goal of this reordering is to optimize the relevancy. And I'll try to explain this relevancy in next steps. So let's jump into the practical example. We have a Richard. It's a famous actor from Poland, Richard. He tries to find an iPhone on our platform. So he used our search, and this is what he got 1 year ago. So on the first position, there was a leather case, but it wasn't the item that he was looking for. The items he was looking for, it was a iPhone, the device. And you can see that these devices are on the second and third positions. So we can mark the relevancy of these items as 0 for the first one. He's not interested in this item. He's interested in the last. So learning to rank algorithm, right? We would like to get the ML model to transform this actual ranking that we got from the raw search engine to build ideal ranking for our users, right? So to have relevant items on the first positions. How do we evaluate this? Because this will allow us to build the ML model. To evaluate, we use quite common metric named NDCG, normalized discounted cumulative gain. And you can see formula here, but I won't focus on the formula. I would like to explain you the main feature of this metric. The main feature of this metric is to stress the items on the first positions, but penalize the items on the further positions. So this comes from the fact that users are mostly interested in the items on the first position. This is like our bias. We are biased in these terms. So these metrics try to fight with this bias. Another important thing in ML learning to rank model is to build dataset. And in next slides, I will explain how to build a dataset. First approach is we could ask our users, right? What's relevant for you? We could get a Richard in our room and ask, okay, you have a query here, iPhone, and we present the list of items and asking like, is it relevant for you, right? The first item, no, it's not relevant for Richard. Second, yes, we marked as relevant. Third one, even though it's an iPhone, it's a device, but it's white and it's not relevant for our user. Fourth position, it's relevant, right? So we have a list marked of relevance for our user. And when we take many of these users in our rooms, we could build a dataset. But this approach, it's very expensive, time consuming. You have to organize the process. So there are many downsides. What's more, users might be biased. Another approach, and this is the approach that we currently use, and to be honest, I think it's widely used by the other e-commerce platforms. It's using the clickstream. So most of the platforms have implemented the tracking of users. So we track the events of the actions on the listing on the ad page. So in our case, we call them user signals of the relevancy. So these user signals can be clicking on buy button, which is available on our platform, clicking on a send message. So there is an interest in the item, right? Users can also click on a call, so to contact with the user, with other seller. But there are less maybe relevant signals, like clicking on add favorite, or even clicking on the ad title. Sometimes in other platforms, it's not our case, but I know others players on the market, they even measure the time of staying on the ad page, which is like more difficult, but it's possible. So this is how we can get the relevancy from our users, and we don't need to invite to our rooms, to our offices. So I explain a bit how this process looks like. So we get a listing from search, and we have to mark the session, right? So to build a session, we basically need a query, right, which is search ID. We need to also concatenate filters, some session IDs from the browser. Later on, we have to get some ad IDs, right? So to collect pair of session and ads. And basically we can get it from our databases. One of the most important things in building dataset is to collect features. And here you have to be creative. In our case, we have few groups, and here I just want to show you a few of them. For example, text similarity, right? So how query typed by user is similar to, I know, maybe title, description, or maybe city, right? People very often tries to find, for example, iPhone, Warsaw, right? Add statistics, it's another group. These are, for example, click-through rate, but it might be also favorite clicks. Another group, it's more like static features. This might be add freshness, so how long the item is on the platform. But it also might be another static feature like price, right? And at the end, the last column that we want to mark is this relevancy, and it comes from the click stream, as I mentioned in the previous slide. Our usual LTR pipeline, it's straightforward. It's a set of creating a data set. For that, we use Trino query, SQL query engine, like maintained by Apache Airflow. Later on, we train model in one of the libraries, XGBoost, CatBoost, or LightGBM, depends on the use case. We save our model in model registry, which is ready for our MLEs, SREs, or software engineers to consume, take it and use it in our search engines, where later they are served as to reorder the rankings. Now I'll tell you a bit about challenges in the OLX group. So this is what we faced during building LTRs. First one is many targets. So normally you optimize ranking, I know, for the one criteria, but on our platform we have a few. First one is organic ads. These are ads that are free on our platform, and basically this is where we started. But quickly we realized that by promoting organic ads, we sacrificed the VAS ads. These are VAS ads. These are the ads that were paid to be at the top by our users. So basically, we were harming our business. Also, another criteria appeared a bit later. It's a pay and ship. So we would also like to boost our items with pay and ship to be at the top. So as you see, we have many dimensions to optimize in our learning to rank algorithm. To somehow mitigate this problem, we use the approach of multi-objective optimization to use this algorithm for where we're building our models. We created a Pareto line on this chart. You can see this red line. This is a Pareto line to find the most optimal models, to find models that satisfy one dimension and another one. Here we have only 2 dimensions, but it might be more. Another challenge is multiple models, right? Here I have only one platform, OLX. We support 7 countries, which means 7 models to train. But every country has 2 types of search: category browsing without keyword, and another type of searching is keyword search, so where the user typed the query. It means doubling the number of models. Later on, we found out that general models are not super ideal in every case. So having specialized models for some categories gives us better performance. We have 18 categories, so it means, okay, building more models. What's more, sometimes we want to optimize for buses, sometimes we want to optimize for pay and ship. Another, like this doubling the number of models. And what's more, we started expanding our solutions to our other platforms. Basically, we call it verticals, so real estate or motors platforms. So this previous problem transformed to another, right? The pipelines hell. Quickly we realized that we are copying the pipelines, and they are very similar in some cases. Always the process of data collection is different, but the process of training is very similar. So our data scientists became experts of Control C, Control V. And to summarize the problem, yeah, we support many countries, right? We have to optimize many targets. So this transformed to the problem of supporting multiple models, right? So our urge is to train more models with different configurations. But what's the worst? We quickly realized that we are duplicating code in many repos. So the process looked like on this picture, right? We were seeing similar code every time. Control C, Control V were used too often. Too often is our case. So we asked ourselves, can we do better, right? So then the idea of LTR framework was created. So we wanted to stop duplicating efforts, mostly for our data scientists, right? We noticed that technical debt started growing, so we wanted to avoid that, right? Also, we thought, okay, merging the work of data scientists could create a synergy between them, right? This can create acceleration of the development and speed up the process of experimentation for our LTRs, right? And at the end, this will reduce costs because we will save some time. So now Ilan will introduce the LTR framework, the core of our.
Thanks, Marcin. So I will introduce the engineering side of things here. How it works is, as Marcin you showed, we have duplicates from everywhere and duplicates of duplicates that are incompatible. So we try to clean everything. I like that the motivation is stop growing technical debt instead of reducing, because to be honest, we're still not reducing it, but we are trying to make everything more streamlined, more easy to maintain, because we are a rather small team to support all of that. So we spend some time in defining what are requirements, what are guidelines, and then we can just train data scientists to use our tools. So how it looks is in the next slide, please, Marcin. And I took the same slide as before, but I'm trying to show basically how it's going to work now. So our raw data, it's basically gathered by all the backend engineers. That's the click stream. That's all the information we might have about the ads, etc. So this is represented here. We have amazing data engineers that make sure that we can query it easy. However, between our different businesses, the data sets, they don't look the same. So the way to gather, collect that data, treat it, and make it into a really nice data set, it's different between the OLX compared to what Motors, Automoto is doing. Is different in real estate, and because the jobs category in OLX is also different, we have basically already 4 different streams to gather this data. That was not possible to unify, so we decided to just keep it as is and not touch it for now. What we focused on is this big factor in the middle. Oh no, wait, yeah, I will just finish quick. This big factor in the middle, so this is the framework, basically is just a library that we are implementing that is using Airflow and Spark to import this data and launch training, and using Hydra, which is a really cool library made by Meta for configuration of machine learning projects. We can ship a lot of models. The reason we really want to ship a lot of models is because as Marcin you showed, we have fine-grained requirements for different number of models. So in OLX, we might want to make a model dedicated for Poland in subcategory iPhone 12. We might want to be doing that. And because we're big fans of A/B testing, we even need to be able to make version A, B, and C work at the same time for this very specific category. So in the past, it was very difficult because we didn't have the tooling. And now because we can focus our work into one library, it's going to be possible. The framework, however, leaves out the deployment. As of today, that deployment is always to Solr, but again, our different businesses have different versions of Solr. And in the future, we might want to do that outside of Solr. So the real importance here is to keep it out. All right, now next slide. Thanks. So first step is obviously to unify the data set, the input source. So the data set, you have to imagine each row is one ad seen in the search page by one user. So when you make a query, you will see in the first page 32 results usually. That means one query ID with your filters, with your search string, etc. You will see 32 lines extra in our dataset every time you make a search and see a new page. So for each of those rows, we have a document ID, which ad was pointed by this given search result. And we also see the rank, which is in which position this ad ID was in the search page. And then we have some features that are available to the model at the time of inference. So at the time you make a search, we have a set of features. And typically that can be, as you showed Marcin before, that can be how well is the matching between the search string and the document title or document description. That can be what is the click-through rate at that given time for this given ad. That can be anything you want, or at least anything we can possibly collect, and that is required by the data scientists. So they are the ones who are asking us to add features there. After that, we have relevance related features. Those are the ones, as Marcin showed, that are collected from the click stream to be able to build a target on which we want to optimize for. So this relevance can be how many clicks or was it clicked. Usually we use Booleans because 1 or 2 clicks doesn't make a huge difference. But also, was it replied? This is usually the most important one that we're looking at. And those are really interesting for us because we can play and try to optimize. We really want to promote pay and ship models. Then in the relevance computation, we will add some bonus points for pay and ship ads, the one that you can buy online and receive later. Last but not least, we have the extra that are usually not available at inference time, but they are really useful for all kinds of analysis and maybe even monitoring. And partitioning, that's country, which platform here means business, and what was the date at which we saw the traffic. All right, I'll give you an example now. So query ID 42, so imagine this is just random ID. The doc ID you can see on each row is different because in this imaginary search we are showing 3 results. The rank was 0, 1, 2. BM25, that's typically what Solr returns you by default. That's like how well is there the matching between the text query and the search document. So that gives you a score, which is a really good indication. By default, Solr would order them in decreasing order, but our ranking system just takes it as one feature and then does more computation with it. You can see we have the CTR here. Those values are really high. Typically, we don't have 98% of clicks on each ad. And you can see, was it replied, or as a relevance metric, you can see, was it replied or not? So that's a Boolean, and that's the basic target that we want. That's the first one we used. And the more replies we have, the happier the customers are. So that's the one we ideally really want to push. And one also very important can be, was it promoted, was it organic? Because obviously promoted gives us more revenue, so that's also what business is asking to make sure that we are not hurting those. All right, then it's just partitioning. Imagine maybe next slide. So once we have this data set, we want to be training the models, but we have tons of different ways. The data scientists, they always want to experiment, try to develop new ways to make a model, and they always have tons of ideas. We also want to be able to, as we said, train for one specific brand, one specific country, one specific category, different versions for each of them. So for that, we are just using Hydra, which is a really good library made by Meta, which allows us to do tons of things. But typically with a YAML, we can compose different YAMLs to be able to tell, okay, this is how I want my target to be computed. This is what features the model is allowed to use to train the model. And this is the model implementation that we want to see. We usually use CatBoost or XGBoost. We use them in total different ways. But for a same data set, you can try both models and see which one returns you the best offline metrics. So this is typically how we do. And then on training time, all we have to do is to change, like make it train for each of the categories that we want with the proper configuration. So from the perspective of a data scientist, it makes things much easier because instead of re-implementing, doing CLI commands, deploying by hand, you just change in our repo those configurations and then everything happens automatically. From there, we are deploying the models. And if you show the next slide, I will show a bit how this deployment logic works. So we have a central MLflow instance, which collects all the training metrics. And we are also labeling the versions of what we want. So in MLflow, you have this feature that allows you to say this one goes to production or not. So that's how we do it, basically. The data scientists, they go look with their own eyes, oh, does it look good? This training look good? And when yes, they just mark it to production, and they can send a link to the backend engineers, and that will develop, that will deploy it, to Solar. And we also use it as a model repo because alongside the training metrics, we also send the raw model file, so the ones that can be used by CatBoost, but also the model that is exported in the format in which we are going to deploy it. So in Solar, that's typically a very specific schema in the JSON format. So those two things will be stored in MLflow. So just the link to MLflow allows anyone to know what we're talking about. What are the metrics? Is it deployed in live? Is it to be used by Solar? And just downloading the file, you can deploy it. Then next, Catarina will talk to you about Y-Labs, which is the performance analysis and tracking. And also we have deployed model cards. One of our issues internally as a rather large organization is to talk to non-tech people about what our model does. Typically people who are responsible for selling this promoted traffic, they are really worried that we hurt this traffic. So for that, we created model cards, which are aimed at giving a recap, thanks Marcin, giving a recap of what the training did, what the model is capable of, what are we expecting it to do, and what people should really look at. So in this example, typically we give some recap about the training data, what the details of the model, but what people really like to see is the average position or the expected average position of bump paths before the model and after the model. If we see that this position decreases, so if it goes to the top of the page for bump paths, it means we are putting a stronger focus on promoting this paid traffic. If we see that the reply position is also decreased, then it means people are finding the perfect offers much quicker than before. So this is what we're comparing. And the NDCG metric, which is really useful for scientists, we figured people don't use it quite as much, and they like this more human compatible metrics, let's say. So this is how we do it, and this is also stored in MLflow. Again, one link can be shared with everyone, and everyone finds what they need to do. And next, Catarina is going to talk to you about the Y-Labs.
Thank you, Ilan. So as Ilan just mentioned, we use two different platforms for monitoring, and starting off with Y-Labs is our main data quality observation and model performance monitoring that we chose due to these features, as well as customizable dashboards. What this means is that we can send our own custom metrics, we can customize it and have different sections of different things that we want to monitor. And we can also, this is also very helpful because it helps us detect and find the problems that are happening in our models, as well as any issue in data quality. And what this allows us is to have a better organization. And in the case of the framework, we have decided to establish this nomenclature where we divide between units and country. And as Marcin previously said, we have different units like real estate, motors, core, And then for each one of those, we operate in different countries. So we will have real estate Poland, real estate Romania, and so on. And having this organization also allows us to have more model readability, since our models will be organized between country, and then inside those dashboards, we are able to view everything that fits our model's need or the project's needs, and we are able to easily understand what's going on. And what also allows us to reduce downtime. And Marcin, if you can go to the next slide. Here is an overview of the dashboard that we have inside each resource in YLabs. And as you can see, there's a summary overview of each section, and each section is called a widget that displays a different part of what we are monitoring or following up, like input health, model performance, anomaly summary, the explainability widget, which is in our case the feature importance of the features the model used. And there's also the monitoring coverage, which is how much we are covering in terms of monitoring inside our resource. And if we go to the next slide, these monitors, we can enable them, the default ones available in YLabs, which are mainly for missing values, unique values, but we also can create our own, which comes very in handy, since we can create monitoring for data quality, model performance for input and or output columns. And then we can also specify thresholds or any other restrictions that we should be alerted if we don't match with these requirements. And then we are alerted in any channel that we think is fit, like our messaging application or even by email. Marcin, if we want to move on. MLflow also complements YLabs, and this becomes very in handy because we are able to keep track of our training and have up-to-date model storage. And this is also kind of customizable because we can keep track of our own parameters of the model, the metrics that can change between projects, as well as keep track tags. And in our case, we have tags for the use features the model used. And then we have artifacts, which are any files of any type that we would like to store. In our case, it's the model cards that Ilan just said, as well as model files. We can go next. And for the framework, currently, we have already released real estate. And this means that for all the countries that real estate is operating in, which means Romania, Poland, and Portugal, we have automated pipelines, MLflow integration, and YLabs monitoring. What this means is that we have, if you go to the next slide, we have daily automated pipelines. Sorry, Martin, can you go to the next slide? Thank you. For dataset creation and model training, one for each country which we are operating, and we have an overall more descriptive overview if everything went successfully. In this case, everything is green, so everything went okay. Next slide, please. We have MLflow for the trained models, and we have up-to-date models. And as you can see, we can look at how the last time a model was logged in there, as well as the model cards and all the other features that I've just mentioned. And finally, for the YLabs, we also have our training data and model outputs, and we are able to compare with other YLabs resources, which comes in handy in this case. In these images, we compare Poland real estate and Romania real estate, and it's nice to have a comparison view. So with that being said, what are the next steps for the framework? So currently we are working in migrating the remaining units into the framework, so OLX core and motors. And having this migrated, we would like to take advantage of these cross-project synergies and identify different features that have proved value in other units, so we are able to also implement them for the other units and use them. And finally, since we want to accommodate growth and ensure performance and have meet the increasing demands of the system, we want to scale up, and this will be a continuous effort. And finally, once we reach a robust and very nice project, we will, why not open source it? And I will not say this will happen, but it's also to have nice to have it in mind and share it with the world, because it's very helpful for data scientists and ML engineers. And this concludes our presentation. I hope you guys enjoyed it. And if you have any questions, feel free to ask.
Thank you very much. We're gonna run very quickly. I found a question on our chat, so let me share this question with you. Is it something like weighted precision? And I guess it's addressed to Catarina because of this @ and K leather.
So in YLabs, we have metrics for precision at any K that we would like. We have the YLabs metrics for ranking. I don't know if that's what you're referring, but we have the ranking metrics from YLabs that we also log into our resources, but we also log our own custom metrics, which are focused on NDCG, as Marcin said, or other metrics that other units require. I don't know if it answers your question. I don't know if anyone wants to comment on that.
All right, thank you very much. I've got also the comment, but this is not a question, and we're actually out of time, so I can only read the comment. I can see what you did there with the number of categories, whatever it means. Thank you very much. It was very interesting, very inspiring, long process, a lot of different stages you applied. Of course, the data is very huge, and you have to deal with very complicated issues. So thank you very much for your presentation. It was, as I said, very good, and see you later.
Thank you.